The goal of exercise 9 is basically to undo everything we did in exercise 8 in the previous video. So there in the previous video and that code, what we wanted to do is create a random numbers matrix that has this correlational pattern. So a random matrix of multivariable random numbers, which are like simulated data, that have this correlation pattern. And then here, what we're going to do is apply this formula to undo those correlations. And that is called whitening. Whitening is used in signal processing, it's used in image processing, computational vision. Whitening is used quite a lot in applied data science. So here is the formula. Now you already have V and lambda from the previous exercise, so you don't actually need to recompute them. And, in some sense, you can see that what we're doing is kind of inverting. It's not literally inverting, but we're just rearranging the multivariable correlation filter that we used in exercise 8 that looked like this. So here we had V times square root of lambda times X, where X was just uncorrelated random data. And then here we have Y transpose, so the correlated data, times V times lambda, and then it's the reciprocal of the square root of this matrix. Okay, and then what we should find is that the correlation matrix of Y tilde is roughly the identity matrix. So you can see there's not a whole lot of new code that we need here. So again, apologies for a bit of confusion after you're watching from the previous video, but this is what I called in the text, I called this matrix Y, and here I called it variable X. So sorry about that. Yeah, then otherwise pretty straightforward. And here we can check the correlations, and here you do see that, yeah, it's not exactly the identity matrix. The goal of whitening in theory is to give this data matrix a correlation matrix that equals the identity matrix, but it's quite close. It's very close to the identity matrix. Another way to describe what we have done here with whitening is to orthogonalize the data matrix. So here the data matrix was correlated. Some variables were really strongly correlated, 0.9. And here we've removed that correlation, so we have orthogonalized all of the features of the data set.